Okay, so if we could pull up the presentation, we've got some students in the room that want to do lightning talks, little advertisement for their posters. Are you all here? Stand, come over here, please. Oh, you're gonna pull it up for me. Okay, so we're gonna start with some of the students that are virtual, and then we're going to have you guys file up here. I have you in the order that I sent you. Oh, I see you all pulling your phones out. Perfect. Align yourselves while the virtual students are talking, and then we'll be done. So just as a reminder, you each have a minute. You might want to get closer to me. Come on down. Okay. All righty. So, oh, okay. I don't have a lot. Ah. All right. Okay, so the first, I suppose, we should say, Sahil, are you with us? Oh, you're here. I had you in the wrong one. Come on up.
Hello. I'm Sahil. I'm from UCLA. And I mean, if you're wondering what somebody who studies the high redshift universe and the first stars is doing at a conference about planetary and lunar science, don't worry, you're not alone. I too was confused when my advisor suggested that I apply. But I've since learned that, I mean, some of you may be more familiar than me, that there are several telescopes that are planned to be put on the moon, one of which is a low frequency radio telescope on the far side of the moon. And among other things, that telescope will be able to observe the 21 centimeter or spin flip signal of atomic hydrogen gas in the early universe. And so while these observations of the early universe are important, it's also equally important that we have models that help us interpret what these observations are telling us. And so with my poster and my projects, I work on describing some of the physics of the first stars and how that'll impact the signal that we might be able to observe with these sort of radio telescopes on the moon. So if any of that sounds interesting, please feel free to stop by. I'd love to talk. Thanks.
Okay, Nick, you're here too. All right, I got it all wrong.
Hi, good afternoon, everyone. I'm Nick Piskrich. I'm a second-year graduate student at the University of Central Florida. My research interests currently focus on using remote sensing observations from the Moon Mineralogy Mapper and Lunar Diviner Radiometer. And my poster talks about constraining what I would say to be some of the most enigmatic features on the lunar surface. They're called irregular Mare patches, or sometimes called meniscus hollows. And their relevance to lunar history is the fact that we believe that lunar volcanism or lunar volcanic processes have not persisted beyond 1 billion years ago. So these features have relatively few superposed craters, as well as evidence of small scale topography that indicates that they may be as young as 10 million to 100 million years old. So I would like to just pose a question to all of us as a group in terms of, is it time that we rethink the lunar thermal history and lunar interior evolution model based on understanding if these deposits are volcanic in origin? And if you're looking for me tomorrow, I will be at the poster session, and I'm planning on dressing in various shades of blue. So hopefully it will stick out.
All right.
Good afternoon, everyone. I'm Benoit Desrochers. I'm a master's student in applied geomatics and remote sensing at the University of Sherbrooke in Quebec, Canada. Now, don't worry, even though I'm Canadian, I'll try and not apologize too much. And if I do so, I'm really sorry about it. So my work at the university revolves around the use of super resolution in space exploration, super resolution being a subfield of machine learning. This specific project was to simulate various Martian sensors being HiRISE, Perseverance, Mastcam, as well as Ingenuity's Return to Earth camera to train 2 models to go from orbital to aerial imagery, and then from aerial imagery to or aerial resolution to ground resolution. The final goal of that was to use those models on real Martian data in order to enhance those images and increase the tactical and strategical decision making. So I'll be at the poster presentation tomorrow, and I'll be happy to answer your questions.
Okay, I know he's not here. Are you online, Carlos?
I am here. Can you hear me?
We can. Please go ahead.
All right. So yeah, my name is Carl, and I'm a master's student in University of Central Florida. And together with my advisor, Daniel Britz and Hannah Surgeons, we have developed PSR IC regolith simulant. And some of you maybe know that in the next few years, we are going back to moon. And some of you have been working in a lab with some moon stuff. Maybe you had to make your own IC simulants. And then when you were making it, you were thinking, hey, wouldn't it be nice if this thing was commercial? So I would just buy my own simulants and just focus on my experiment, not on making stimulants. So this is why we thought this would be a nice idea to develop it. And come to my virtual poster and see for yourself. Thank you.
Chiara, there you are.
Hello. Ooh, that's not my talk, but I'll tell you what my talk is. I'm Kiara Ferrari Wong. I'm from the University of Hawaii at Manoa, and I will be giving a talk titled Rockstar. It'll be in big letters. And it is a mission concept for a thermal infrared hyperspectral mapper. It will be operate between 6 and 12 microns, which will enable mapping of the lunar surface of molecular water as well as silicate mineralogy. It is compatible with very small satellites in the 50 kilogram class because it's about shoebox size, a little bit smaller like this. And it will also be able to provide images around 1 to 6 meters per pixel in spatial resolution, which is great for looking at large boulders and small fresh craters. We hope it will enable pre-mission EVA planning for upcoming missions. There's also other applications for this technology, so stop by my poster, Rockstar, tomorrow if you want to learn more. Thank you.
So look up hers and make sure, it looks like I got it wrong. Hopefully they're not in a series of errors here. Okay, Lyndon.
Good afternoon, everyone. I'm Lyndon, and this is the talk that I'm presenting tomorrow, so that's a plus. As you may know, my name is Lyndon. I'm named after a type of tree. So one day I hope to maybe be the first vegetation on the moon. But for the purpose of the rest of this minute, I'll be talking about the moon adjacent Kilbourne Hole, which is a Mara crater in New Mexico used by the RISE 2 team as a lunar analog site for operations. However, this past November, I was lucky enough to be invited out as a member of the GEODES team to perform seismic surveys of the crater rim. We did surveys of the ash deposit, the surge beds, and the basaltic lava flow to get some details about the subsurface structure. And we fortunately had the LiDAR team from RISE to collect data of the slope where we took our seismic surveys, which is important for making more precise estimates of the subsurface structure, which can be used by astronauts in field data training. So I hope to see everyone at my talk tomorrow. It will be at 5:30 p.m. in person with this title. Thank you.
All right, Dominic.
Hello, everyone. I'm Dominic Alfanito. Says I'm with North County High School, but just starting first year at University of Maryland, Baltimore County. So my work focused on Vesta's Opia crater. And the reason for that is we've known for a while that small bodies like Ceres are icy and contain hydration features. But Vesta to date has been assumed to be quite dry, but the exception to that is a particular crater known as Opia crater. It's about 235 million years old and it's about 30 kilometers wide. Its ejecta blanket is only to one side of the crater, and it possesses a pretty notable absorption within the 2-micron band depth. So my work used some Dawn data, and it looked at that range, and I made a comparison to it as well as hydrogen neutron counts. And our work was really to determine whether or not it was a hydrated impactor or a subsurface hydration feature that was exposed by an impact event. So if you want to know the answer to that, then see me at the talk tomorrow.
Samuel, I think he might be online.
Hi,
Yeah.
my name
Go
is
for it.
Samuel Lin, and I'm from the Middlesex County Academy for Science, Math, and Engineering Technologies. So done in collaboration with Dr. Peter Chi from UCLA, my poster is on a compact rover for exploring lunar and Martian crustal magnetic fields. Rovers are ideal for gathering magnetic field data on Mars, but they produce magnetic interference. The premise behind this project is to develop a rover prototype that has an array of magnetometers rather than just one. This rover was designed from scratch and contains a magnetometer array, as I mentioned before, and also a lift system to gather magnetic field data both in and around the rover. And using this rover, we will test calibration methods to eliminate rover interference for extremely accurate sensor readings. The array of magnetometers give a more detailed image of the rover's magnetic signature, and the arm will help verify these results. This project will reveal important details about magnetometer calibration on Mars and will advance studies about the origin of the planet. More details on premise design and current progress can be accessed on my poster. Thank you, and I hope to see you at the poster session.
Thank you. All right, Autumn.
Hi, everyone. My name is Autumn Shackelford, and I am a second, almost third-year planetary science graduate student at the University of Central Florida. And I will be presenting a poster on a new ultra-high vacuum space weathering chamber called SWEEPS, or the Space Weathering Environment for Exploring Planetary Surfaces. This is a simulated environment system designed to mimic multiple environments throughout the solar system, including cometary environments, icy satellites and ocean worlds, and airless bodies or exospheres, such as asteroids, the moon, and Mercury. The design for this system is based around a custom-built cryostat with an extended sample holder that can host condensed gases, liquids, powders, and solids at temperatures ranging from around 10 Kelvin to 1000 Kelvin. This system is also designed to allow for bidirectional reflectance measurements that are operate continuously over 0.4 to 25 microns. And there are several additions we can make to this chamber to create a true space weathering environment. But if you want to hear more about those things, you can come find me at the poster session tomorrow at poster 61. So thank you.
Okay, next up, Elena.
It's always a good start when you trip walking up. Hi, I'm Elena. I go to the University of Colorado and I work at Impact with Shu Wong, Sean Shu, and Mihai Harani. I'll be doing a poster on spectral variation caused by dust lofting. We see that size sorting can cause spectral changes as different sizes of dust have different reflectance measurements. And we're gathering data on that. So please come and stop by tomorrow, poster session, and I can't wait to see you all.
Okay, Cassie.
Good afternoon. I'm Casey Baracchia, and I'm a master's student at the University of Maryland. My research focuses on experimentally characterizing lunar analog materials, and it's a part of the larger NASA GEODES project, which looks at geophysical methods to understand the lunar surface. So my role in this has been to go out in the field here on Earth and collect samples at field sites that are analogous to the lunar surface. I then bring them back to the lab and I crush, compress, and torture these rocks as I also simultaneously collect ultrasonic seismic velocity measurements on them in order to look at the sort of physical features of these samples at varying porosity measurements. I also look at the seismic signature of these samples at a small hand sample scale level and compare that to the larger field seismic signature. So if any of that sounds interesting to you, please come chat with me at my poster tomorrow. Thank you.
Okay, Edward? Nope. Okay. So are you online, Edward?
Yeah, I'm here. Can you hear me?
We can, go ahead.
Oh, okay, thanks. Hi, I'm Edward Williams. I'm at the University of Maryland, College Park, and I've been working as part of the GEODS team as well. And my co-authors are Laurent Montesi, Patrick Welly, and Ernie Bell. I've been working on studying Valentine Cave, which is a lava tube in California. I've been modeling this cave to see if inflation, while it was forming, could cause the surface ridge that we observe on the surface above it. I've been using different parameters within the realistic ranges of what these parameters could be, and I've found some new conclusions about how inflation could have caused this process and what the parameters of the tube must have been at the time. And if you'd like to find out more about that, please come by my virtual poster on Thursday. Thank you.
It's like lucky dip. Which way are they going to connect? Not Brandon. Okay, Brandon, are you on? Okay, I might have added this one and maybe he wasn't going to be. Okay, Christopher. There we go.
Hello, everyone. My name is Christopher Scholand. I'm from the Georgia Institute of Technology, and my poster is on the investigation and development of 2D and 3D EDS towards the creation of a hybrid dust mitigation brush. This project started as part of the 2021 Big Ideas Challenge put on by NASA, and has also been working with the Survey and Reveals team that is at Georgia Tech and a few other universities as well. The goal of this project is towards helping astronauts to stay safer on the surface of the moon by giving them a tool that they can use to mitigate and remove dust from their spacesuits. We're trying to accomplish this by combining a few different mitigation technologies of EDS, which is electrodynamic dust shielding. We have the UV radiation, and then we also have mechanical brushing just with bristles. The work that I have specifically on the poster is looking more at a new direction we've been taking with EDS using a chemically modified reduced graphene oxide, and then also looking at how the EDS system interacts with UV. So if you want to see more about this at my poster, just go to the poster session tomorrow, look for the abnormally tall person. I'll probably be taller than all of the posters, maybe, we'll see. And yeah, please come talk with me and learn more about the work that I've been doing. Thank you very much.
Okay, and Alicia.
Hi, I'm Alicia Vera. I'm a graduate student at Georgia Tech. I'm part of the Reveals project. And I will be presenting on radiation exposure to boron nitride, both GEANT4 simulations and experimental. So our approach is like three aspects to it. The first is we're using Monte Carlo simulations to determine the most optimal radiation shielding material. And then the second part, we're sending some of our samples to the Space Force. We've actually already sent this. And then lastly, we're exploring ground-based exposure studies for the radiation dosimetry. And if you want to hear more, please come to my poster session. Thank you.
Okay, well done to all of you and thank you. I want to remind everybody, oh, yes, Carly was about to